Hi, this is Mike Heumann from G2M Research, welcoming everybody to our multi-vendor webinar on scale-out storage best practices. Let's give everybody about 30 seconds to sign in, and then we'll go ahead and get started. All right. So quick going through the agenda here. We'll start out, I'll do a quick introduction of the speakers and talk a little bit about the ground rules. Then each of the different vendors, and we have 3 of them, Accelero, SolarFlare, and Noesis, will get 5 minutes to present a little bit about themselves. After that, we'll have an audience survey question. Then we'll go into the vendor questions. There'll be 3 of those. Each vendor will get to talk for about 4 minutes. At the end of all that, we'll have an audience Q&A and wrap up at about 10:15. So joining us, we have Josh Goldenhart. Josh is the VP of Products from Accelero. Also, Scott Schweitzer. Scott is the Director of Technology Evangelist at SolarFlare. And then Dan Liddell, who is the VP of Marketing at Noesis. And I am Mike Heumann. I'm the Managing Partner of G2M Research. So one of the questions that we often get asked in these webinars is, what's a storage array versus what's a storage appliance, and how does scale-out storage kind of fit into all that? So from our perspective, a storage array is a system that's sold as a single piece. It has all the software and hardware built in, all as one. It's supported by that one particular vendor. I mean, examples of this would be Dell EMC, NetApp, Pure Storage, IBM all sell what we think of as classical storage arrays. A storage appliance is really an industry standard server that's running a third-party storage management software. Historically, that's been companies like Accenture, DataCore providing that software. Oftentimes these are integrated by resellers or SIs who put it all together. And it historically has been thought of a poor man's storage solution, kind of just better than gas. And that's changed quite a bit over the years now, especially with NVMe and now the entry of scale-out flash storage. So if you kind of look at how they really changed the landscape, flash especially, but NVMe in particular, has really changed the media latency. The disks, you had to spend a lot of time and energy and engineering to try to get speed out of a storage array, and that's what the storage array vendors did. With flash, it's a lot easier, and NVMe's made that even more so. So that's really made it kind of closed the gap in performance between what have typically been thought of as storage appliances versus storage arrays. One of the other things that we've seen too is that the increases in Ethernet speed have really kind of impacted the advantage of fiber channel for SAN. So historically, storage arrays have run on fiber channel and storage appliances have run on Ethernet. There have been, of course, storage arrays that support Ethernet as well as InfiniBand and other protocols as well. But now with the 100 gig Rocky or 100 gig Ethernet coming along, and Rocky and soon NVMe over TCP, a lot of those speed advantages have really went away. And now you've got basically shared SAN LAN that can provide the same performance as fiber channel. And finally, one of the other things you've seen is as well is a lot of storage arrays today now run on x86 architectures, use less ASICs and FPGAs and other things that they historically used to provide the performance they did. So what you really see now is a situation where the lines between what is an array and what is a storage appliance have really blurred. And one of the questions we get asked is, why is all this important? Well, historically, if you looked at arrays, they were significantly more expensive on a cost per gigabyte metric than, say, storage appliances were. That was kind of a big issue for a long time. That is still true today. One of the other things is data management and backup. It's always been hard, even with an array, it's been difficult to back up and recover things online or in time. Today, most apps take care of this, so it kind of has gotten rid of another advantage that arrays historically have had. And then finally, support. As array vendors have moved to standard server hardware themselves, they've become more and more software vendors as well. So, the question you kind of ask yourself is, why pay more money to get kind of the same performance and scalability? And that's kind of where I think we sit if we look at arrays versus storage appliances today. And with that, I'd like to go ahead and introduce Josh from Accelero. Josh will be walking us through their slides.
All right, thanks very much, Mike. And I'll take 5 minutes now to tell you guys about Accelero and our scale-out server SAN product. And server SAN was a term that's been coined by the different analyst groups, which we won't name. But basically, the idea is that you take standard servers and you layer our software on top, and then you get SAN functionality. And it's a lot of, Mike, what you touched on. So let's go ahead to the first slide, please. So what is NVMesh server SAN? Well, my company is Accelero, and our product is NVMesh, which stands for non-volatile mesh. And what it lets you do is take standard off-the-shelf servers that contain NVMe flash. We connect those with either Ethernet or InfiniBand, and the majority of our customers these days are actually choosing Ethernet. And we unify that pool of NVMe flash across the servers, and utilizing methods such as NVMe over Fabric. We take that NVMe over Fabric, which is just a transport, and we make it into a complete storage solution. So a lot of times there's confusion that people say, well, NVMe over Fabric, that's all I need, right? NVMe over Fabric is, quite frankly, remote DAS. If you have a whole bunch of NVMe drives and you access them over the Fabric, you're going to have hundreds or thousands of separate entities. We unify all this into a pool. We allow you to do different protection levels. We allow for host failure, drive failure, all with a unified standard interface with centralized statistics, management, a RESTful API. And at the end of the day, what you get is a logical block volume that operates very much like a SAN, that you can attach these logical block devices to multiple client hosts. And on top of that, you either use it raw, or you put your favorite local file system or a shared file system, including solutions like Oracle ASM, for example. So we unify your NVMe, we make it behave like a SAN, and then you get what was already kind of referenced by Mike's previous slides. You get to use Ethernet, which is about 3 times the bandwidth of Fiber Channel 32, but at half the cost. Next slide, please. So what can you do with this? Because I can sit here and tell you about what we do, but why should it be important to you? So one of our nicest wins, public wins recently, was a little company called Technicolor. So if you're excited about films and movies that have been coming out, you'd understand that up to the last 3 really major blockbusters in a particular universe were post-processed by Technicolor using NVMesh. And what NVMesh allowed Technicolor to do was work the way they want to. What I mean by that is they used to only limit, let's say, a single post-production workstation or a single playback room. What we let them do is actually get all the bandwidth out of their network, all the bandwidth and IOPS capability and low latency of the NVMe, but use that over the network to do very, very high rate streaming, 4K video. And when they're editing, doing overlays, they actually might be doing multiple 4K streams to a single workstation. So we're letting them do this work against a centralized file system and not break their workflows. Rather than copying data around, taking minutes to hours, they're working directly against a shared file system. They can have many, many workstations going simultaneously, and they're getting full utilization and efficiency out of their NVMe. Next slide, please. Cynet. Cynet is an HPC customer out of Toronto, Canada, for the University of Toronto. Cynet is using us for burst buffer. So if you're familiar with HPC, what this means is if you pay a whole bunch of money for a supercomputer, you want that supercomputer to be computing. When you do what's called a checkpoint operation, it stops computing, and you have to wait until the checkpoint is done before you can go back to computing. So we enable very, very high rates of what's called burst buffer, very, very high bandwidth write speeds that let the supercomputer finish in a fraction of the time it used to, but at half the cost of the traditional solutions that Mike was referring to. Traditional solutions being arrays, classic arrays from a hardware vendor. So all the speed, very, very low latency, but at half the cost of traditional arrays. And next slide, please. CMA. CMA is a high-end shop that lets you do analytics on top of Oracle. They are experts at deploying Oracle RAC, and in fact have their own solution that they deploy called Microterabyte. We're very happy to partner with them, and what they found with our solution is that they could do the same work that they were doing against multi-million-dollar VMAXs and an 8-node Oracle RAC cluster. They can do that same work with only 3 nodes. And for those of you who are familiar with the costs of licensing Oracle on a per socket basis, this meant that by dropping from 8 nodes that were 2 processors each, or 16 socket licenses, they dropped down to 6 socket licenses, doing the same amount of work. They're achieving speeds of over 20 gigabytes per second per Oracle RAC node against storage. And this is all on top of standard Dell servers. So they took off-the-shelf servers, NVMe, put our software on, and they get a SAN functionality that lets them reduce their licensing costs by 62%. And this is in addition to the capital acquisition costs being far lower than a proprietary array. So you can do more with a lot less. You no longer have to give up performance to get less expensive. And that's one of the key things about our product. I think that might be it. Is there one more slide? Toito. Our last one we'll cover is Toito. Toito is a web cloud provider who's providing Oracle services in the cloud under OpenStack. And Toito improved their overall IOPS by about 20 times while getting 10x lower latency. They were using Ceph before, and with our solution, they simply found that they have no more limit. So they can go ahead and have Oracle in the cloud and get very, very high operational bandwidth, IOPS, and really provide a level of service that they didn't think was attainable before. So that's what you can do with NVMesh, and thank you for the opportunity to tell you a little bit about that.
Thanks a lot, Josh. Let's go now to Scott. Scott, if you could walk us through your part.
You got it, Mike. Thanks for the opportunity. For folks not familiar with SolarFlare is the network interface card that goes in the server. It's used in over 95% of the electronic trading servers around the world. These are from the exchanges like NASDAQ or CME or BATS or Direct Edge, all the way out to the large banks, Citi, Morgan, Chase, you name it, and SolarFlare is doing it. So our focus has been ultra low latency for quite some time. You know, when you're talking about electronic trading, it's all about how low the latency is, because time is money in that market. So if we look at NVMe over Fabrics, that directly applies to Fabrics. Storage and latency have kind of gone hand in hand since the 50s when we first started doing storage. So if we look at networks, we start at the bottom of this chart. InfiniBand has been around for the past 20 years or so. It's a very special purpose network designed for high performance computing. These are 2 networks that are extremely deterministic, designed to solve a specific problem, you know, computing the weather or crash simulations or, you know, airflow roaming, that kind of thing. You know, using that InfiniBand for storage, it means that you'd have to bring yet another network into your data center, right? You already have, or you may already have, a fiber channel network in your data center, and I'm sure your fiber channel networking guys have conflicts every now and then with your traditional networking guys. So, you know, the move is essentially to a single network. Over time, Ethernet has kind of crawled over and crushed every other network technology out there, from IBM's Token Ring to AppleTalk to MirrorNet and others. So as we get up to 100 gigabit Ethernet and beyond, all this stuff is going to be on a single converged fabric. Now, some would say that RoCE, RDMA over Converged Enhanced Ethernet, is the perfect fit for this. The issue with RoCE is RoCE depends on, because of the RDMA component of it, it depends on a deterministic Ethernet network. And for the real Ethernet folks out there, one thing Ethernet isn't is deterministic by its very nature. It was originally a DARPA spinoff designed to sustain outages of networking elements and route around them. So, it's possible to have performance networking without necessarily having a deterministic Ethernet. So let's go to the next slide, Mike. So here's the actual NVMe feature roadmap from the NVMe Express group. If we actually drop down into 2018, we can see that NVMe over Fabrics 1.1 is going to have TCP as the transport binding approved sometime in, it says Q2 in this chart. Turns out the vote will probably be in the next month or so. So we expect that TCP will be approved and approved transport. We've done a lot of work on NVMe over TCP the past 2 years, and that'll become obvious in the next slide. So why don't you go to the next slide, Mike? What we have here are 3 charts. The left chart is a random mix of IOPS. I know this is a little bit of an eye test, and you have to all zoom in to get a flavor for it. But the curve on the top of the left chart, the dark blue curve, is local NVMe performance, and then you see the networks are almost all piled up next to it, with the exception of remote iSCSI. We'll ignore that one for now. The tan and the red networks are NVMe over TCP. Those lines are a little bit below, but that is a generic NVMe over TCP kernel driver that SolarFlare provided the community back in 2017 that runs on anybody's NICs. And we actually ran it on both a SolarFlare NIC and a Mellanox NIC, same code. So you can see that there is a slight discrepancy between the two, but for the most part, we're delivering performance that's on par with RoCE and other things. It's within 5% or so, more or less. Then when we go to the sustained random reads and writes on the right side, these graphs are a little compressed, but these are latency focused graphs as opposed to IOP focused graphs. The latency actually is right down in there with remote RDMA solutions as well as others that are out there. So in the latency space, SolarFlare is kind of the king of network server side latency. By contrast, in the trading world, we're in the 900 nanosecond half round trip for moving TCP and UDP packets around, to give you kind of a flavor for where this is. And remember that disk drives used to be measured in milliseconds, and that's 6 orders of magnitude between the two. So there's substantial gains that have happened with networking in the last 10 years or so. Mike, let's move to the next one. Please, thank you. So our engagements to date, if you look on the top left up there, you can see that SolarFlare submitted our TCP module compliant with the RFC back in the first quarter of 17. We've been an active member of the NVMe group. We demonstrated in Q3 of 17 with a tier 1 OEM, which was Supermicro, viability of TCP as an NVMe fabric. Using SolarFlare technology on generic adapters and a regular Linux kernel. And then later on, Q1 of 2018, we demonstrated, or we validated it actually with both Supermicro and with Dell. So we made quite a bit of progress over the last year and a half or so in this space. Mike, why don't we go to the next slide? So just to kind of wrap it all up, keep it short for y'all. We believe that NVMe over Fabrics over TCP is the way to go. Bar none, Ethernet will eventually win out at the end of the day. We're delivering 25 gig Ethernet adapters today. We've been delivering 40 gig adapters for a while. We've got 100 coming out in the next couple months. That's 100 gigabit Ethernet. And so when you start mixing storage over ultra low latency Ethernet adapters with other traffic, you can really see some gains overall. Improvement and dramatic improvements in online transaction processing, real-time analytics. And, when it comes to advancing this even further forward, most of Solarflare's performance work in ultra low latency comes in doing kernel bypass. And we've got some stuff in the works to take that kernel bypass technology and move that into the NVMe over Fabrics support, which will dramatically drive latency down even further. So that's where we're going. If you guys have any questions afterwards, I'll be happy to entertain them. Mike, back to you.
Thank you, Scott. Thank you very much. And going now to Dan Liddell. Dan is VP of Marketing and New ISIS.
Good morning, everybody. I'd like to thank Mike and the G2M team for organizing the event today. We're excited to discuss scale out NVMe flash storage best practices and give you a little sense of how we view that world. My background has been many years in storage. I run marketing today for the New ISIS group of Sanmina. Been there almost 7 years. We've mainly been in stealth mode, during which time I was running sales. So I've been really working closely with customers for a lot of years. We've been deploying in some of the very largest hyperscale data centers in the world, some of the most profitable, most well-recognized brand names at tremendous scale. We have also sold as behind the scenes as an OEM to the major storage vendors, our platforms that they release under their name. So a lot of folks haven't heard of us because we've been semi-stealth, but we've actually been around for quite a while and have quite a large footprint, especially in hyperscale environments. So with that, we go ahead and jump right in. Next slide, please. Thanks. Yeah, there we go. So just a snapshot on New ISIS, as you likely have not heard of the company. Sanmina is a large global contract manufacturer, $7 billion a year. New ISIS is a dedicated division, storage and serving division within that organization. We have lots of experience and leading edge platforms that we've been developing over the years, coming to market with under other folks' names, as I mentioned. We've got award-winning compute and storage platforms, one I'll talk to you about in a moment, but just at last year's Flash Memory Summit, we won the Best of Show award when stacked up against everybody else, and that was for our NVMe over Fabric solution, which we'll talk about in a minute. But we have all flash and hybrid storage and servers. We've got, of course, NVMe flash-based storage servers and NVMe over Fabric platforms. We have primary and cold storage servers and expansion arrays as well. So we have a big part of our business that is also very large and growing. That's not associated specifically with flash. We've been around for a while, as I mentioned. We have achieved a number of firsts in the industry, and those firsts relate to things that touch on high density, high performance, capacity, and so forth. So we were the first to market with these 4U systems that at first could handle 60 drives, large form factor drives, then 84, then 96. And that was just in the JBOD side of business. We then came out with 2U systems that could handle 60 drives with single or dual servers. We continued on into NVMe PCIe JBOFs, where you can just hang an external NVMe box out the back and attach to servers. We're the first to market with that as well. And then we also came out with the first production-ready NVMe over Fabric storage platform. Again, I mentioned that was one that won the award last year. But really what we do as a group is we focus on product innovation that delivers performance, capacity, cost leadership, and gives you great efficiency from a power and cooling footprint perspective, which is so critical to those large hyperscale data centers. So that's a snapshot about what we're doing. Next slide, please, Mike. So when we think about best practices, obviously this is an evolving, ongoing market that's changing rapidly right now. So the roadmap matters. What you're developing matters. It's changing as new applications are enabled by these tremendous latency, throughput, and overall performance advances that have been developing. It is still maturing, as we all know, and adding services and functionality as we go. Prices are coming down over time. And that, of course, is creating greater use cases and applications, which before would have been considered cost prohibitive. So there's a lot of dynamic changes happening in the space right now, which is exciting, and you need to stay abreast of that and offer a wide platform. So this really does matter, having a broad set of platforms that can be used for the particular application you have in mind, that support numerous best-in-class, third-party, purpose-built software that allows the alignment of the underlying hardware platform and the configurations of that with the particular application that you're using so that you have the greatest TCO efficiency. And then, of course, if you've got fewer vendors to manage, that can make life a lot easier, especially if those vendors like ours, like us, really emphasize the importance of interoperability. So this, we believe, is paramount, supporting those other components and aspects, the third-party drives, cards, software, and so forth in these platforms allows you to offer solutions that are very tailored to be the most efficient and most effective for your particular applications. And of course, it also avoids vendor lock-in, reduces overall system costs because you have more choices from your supply flexibility and so forth. So that's sort of our big picture, high-level view there. Next slide, Mike, please. So to give you kind of a sense of the platforms we have out there today, and there's others that are being released here shortly. You'll see a couple here. I've not released the model numbers, but they will be discussed shortly at, say, upcoming shows, maybe at Flash Memory Summit even. That's just a couple weeks out. But, we've got the range of platforms, everything from a 1U device that can handle 8 or 16 NVMe drives, as well as 1 or 2 servers. So great flexibility, incredible, and a great platform for scale out and for high performance computing as well. We have a 2U24 device that is that JBoss I mentioned, where you can just have external shared NVMe, and that can give you a much larger effectively pool of memory for those boxes. It also gives you redundantly connected high performance storage there as well. We have a quad server device that's in a 2U form factor with 1, 2, 3, or 4 servers, all connected, loaded up with 24 NVMe drives, plenty of connectivity in the back. So this is a very popular unit as well. We have our NVMe over Fabric device called 2248 2F. This device allows us to integrate cards and components from partners who are doing, say 100 gig bridging to PCIe cards in this box, and you can put many of them in there, along with the storage, the 24 NVMe drives, and you can go out the back with, say, 100 gig Ethernet interface, and this is the foundation for your NVMe over Fabric design. And this is one, again, that we showed previously that won the award because we were able to take different vendor software packages, put it on top of different vendors' drives, depending on the characteristics we wanted to achieve, the different vendors' cards, tie it all together in a single package, and that's an exciting platform as well. We have a couple other new platforms that are coming out and will be announced shortly. Just to give you a sense of this, you're hearing about specialty form factors that are coming out where you can take a traditional M.2 carrier and say put a whole lot of U.2 NVMe in there, so you get incredible density. So we're going to continue to lead the market in terms of density, capacity, footprint, and overall throughput of these systems. We have another device here, again, no model number shown, that you'll hear about shortly, that allows you to get to just in a 2U form factor, 56 drives, NVMe drives. So you can imagine the tremendous throughput of the system. And that includes servers. You can have single or dual servers. There's a number of things you can do there. So we continue to push the envelope in this space. We'll continue to broaden these platforms and work with particular software partners based on the particular best-in-class application that they provide, and then jointly sell that solution to customers. That's been very effective for us. Next slide, please. So that really wraps up what we're up to. I'm looking forward to the Q&A section, and I'll hand it back over to Mike. Thank you.
Thank you. Thanks a lot, guys. Now we're going to the panel questions. We'll start with one panel question, then we'll go do an audience survey after that. So for each panel question, each vendor will get 3 minutes to answer the question. And they've seen these up front, so they'll know what they are. If you guys have any questions, by the way, feel free to use the Q&A box. We'll answer those at the end of the presentations. So first panel question is, for many people, scale-out flash storage is synonymous with software-defined storage. And those people also equate today's SOFS solutions with those from 10 years ago. How would you say that today's offerings differ from those of 10 years ago from the standpoint of the user? And we'll start with Accelero.
Thanks, Mike. So this is Josh from Accelero, and of course, I'm going to have a spin on this that's very close to my product. And to answer the question directly, I'd say that solutions from 10 years ago, and some solutions only from 1 year ago or 2 years ago, are software-defined solutions, but they really, to say that they were architected for Flash, and especially NVMe, is a stretch. So I think that's the biggest differentiator. What you had before was software-defined solutions that worked with block devices, whether those block devices were a spinning disk or whether they were a SATA flash device, or even if they say they work with NVMe, they are working with NVMe using an NVMe driver, which at the end of the day shows up as a block device under the kernel. So really these things were architected to take a whole bunch of block devices and then lay something on top of them. So the performance you got was the performance of the design, and that design was really not for the latest and greatest devices, the latencies that NVMe can achieve. So that's the biggest difference. Solutions like Accelero NVMesh were specifically designed for NVMe. When we access NVMe drives over a high-speed network, we only add 5 microseconds of latency, and that's important. I think it was Tom who actually mentioned spinning drives. You know, were measured when they were good. They were at the 8 millisecond range. We're kind of talking about NVMe drives that can do 20 microsecond writes and under 100 microsecond reads, and we add such a minimal amount of overhead on that solutions like ours, NVMe over fabric-based, or our protocol called RDDA, which is even lower latency, when we use these things, we're adding just fractional microseconds. So you can't take a device that is 100 microsecond response time, for instance, and use traditional software-defined storage, which is going to add milliseconds of latency. I don't want to pick on open source, but solutions like Ceph that are very popular, they're good. Ceph is good for what it does, but if you tune the heck out of it and use the most expensive hardware you can and networking, you get it down to about, at best, I think the record is a millisecond or 1,000 microseconds of latency. But if you use solutions, for instance, like Accelero NVMesh, you can get remote reads down to sub 100 microseconds and remote writes in a protected mode at about 30 microseconds. So we're talking just about this enormous chasm of difference in expectations for the total number of IOPS, for the amount of latency, and what you can do there. So the big difference, to come back to the question, is simply that modern solutions are designed for the media, whereas traditional software-defined solutions were really designed for any media. Their main goal to lower cost. We're out to allow you to enjoy lower cost, but have no cap on the performance you can get to.
Great answer, Josh. Thank you very much. Scott, SolarFlare, what is your perception?
Well, like everybody else on the call, I'm going to have my own angle on this. Yeah, I think it's more along the lines of the device and network intelligence along with performance. The devices are getting, more intelligent. The controllers are getting more intelligent, and all of that is going to depend even more on, improved performance and rapidly accelerating, how fast we can get, storage out to customers. I mean, Josh was talking about numbers like 5 microseconds up to 100 microseconds. For storage accesses. And you think about these numbers and you contrast them to the milliseconds that everybody's been used to for decades. And you're like, wow, this is just an amazing jump forward. And then, SolarFlare has been in the nanosecond range for network accesses for probably the last five to 7 years. Our customer base is used to, 100 to 200 nanosecond improvements every time we turn out a new product line. You think to yourself, 200 nanoseconds when I was used to, 20 milliseconds. There's a huge gulf there. So SolarFlare is really kind of focused on how do we take and remove all the latency from the equation, at least on the network controller and the stack that has to respond to that. We'll be rolling out technology probably within the next year or so that will allow us to do a lot of this stuff in the tens or hundreds of nanoseconds space within the adapter. So it'll be interesting to watch how all this advances moving forward. So that's kind of our take on it.
Thank you, Scott. Dan from New ISIS, what is your view on this?
Thanks, Mike. Well, 10 years ago, scale-out had 3 challenges that needed to be overcome. Proprietary solution, single vendor solutions that lock customers in. You mentioned that earlier. expensive total cost of ownership. These solutions 10 years ago didn't leverage industry standard designs and were high cost for integrated hardware and software solutions, very complex. And planned obsolescence. As new hardware came out, there was a forklift upgrade required to take advantage of that new hardware. There's no real future proofing. So New ISIS, we think about this. We can leverage the advances of industry standards with these innovative and patented intellectual property to provide customers with storage solutions that are interoperable, that have attractive total cost of ownership, and can grow non-disruptively over time with investment protection, which is critical today. So we address scale out flash storage with best-in-class packaging, where we lead the industry with these solutions that take up less footprint, require less cooling, demand less power, and so forth. And this is a great example of how new platforms we'll be announcing shortly here in the 2U 56 capacity that I mentioned to you before. I'll take this opportunity to just sort of provide a little more color on the kind of systems that we're developing, and based on that win we mentioned just recently, just at the last Flash Memory Summit, we were recognized for that Best of Show award for NVMe Fabric. We were demonstrating interoperability across multiple vendors at different levels, system integration that achieved with our partners. I think we were seeing in this system, we had between 5 and 7 microseconds of latency across a mesh network that let you connect via 100 gig, which is impressive now. So we were using in this particular configuration, but we could use any vendor's components. We used Intel Optane SSDs, providing really high throughput, but very, very low latency, QoS, and great endurance. In that case, we also had the Mellanox Spectrum 100 gig switches and the ConnectX HBAs for the simple connectivity. In that case, we also have to use Kazan NVMe over Fabric bridging card. We support multiple vendors, of course. And then we just happen to put an IBM Spectrum Scale software package on top of that, just to give an example of enterprise grade parallel file system running across all of this to show you that it's not a tech demo, it's actually an applicable real world use case, and you could pick your favorite software package that goes on that. And we were very pleased to win that award and have terrific response. So that's sort of our view of how things have changed over the last 10 years and something we're quite proud of now.
Thanks, Dan. One thing from my perspective, I think that's really changed a lot is if you think of back in the software-defined storage days, you typically had, a few storage appliances that serviced a bunch of clients. I think the biggest thing with scale out now, and I think Josh, certainly your company is one of the bigger leaders in this area, is the fact that you can have, hundreds or even thousands of storage nodes servicing your users, which I think is a big deal. It certainly opens up the possibilities for new kinds of architectures. So that's kind of my view on it. Okay, going to the audience survey question. This question is, what would be a key factor for you and your organization to consider deploying a scale-out flash storage solution versus an all-flash array? And this will be a check that all that apply. Let me start the polling here, and we'll get that going. Well, it looks like we're having some problems with the online polling at this point. So let's go ahead and go to panel question number 2. Hopefully if we can get if it starts working again, we can go back and answer our question. So panel question number 2 is, the term scale out is being used by everyone in our industry today, from cloud service providers and software as a service providers who talk about things like scaling infinitely, to network vendors, server vendors, and application vendors. Basically, everybody is using the term scale out. So for storage solutions, what does scale out mean to you guys, and what are the factors that need to be considered when developing a scale out flash storage solution? And we'll start this one with SolarFlare.
Thanks, Mike. Scale out, or even in our space, one more network focused, is hyperconverged. Means managing extremely wide server deployments. We're talking, companies like, Citi or others that, have tens of thousands, hundreds of thousands of servers deployed in a single location. You know, these networks need high performance networks like 25 or 100 gig Ethernet eventually. You know, we call these scale out networks neural class networking, right? Because as the server core counts grow, you know, beyond 40 cores on an Intel box eventually, you know, multiple CPUs per box, you know, and then we deploy hundreds or, you know, maybe even eventually thousands of containers per bare metal server. You know, these deployments explode and they become, you know, in the realm of biological systems, and hence, you know, our affinity towards neural class networking. So what we're looking at is we're focused on how we can drive these networks, you know, the latency of the networks down, provide the tools and techniques necessary to manage the networks, pull the required telemetry from the networks, look at the analytics, provide analytic tools, you know, so you can analyze them and figure out where the problems are, and just, you know, tune these things to provide the best possible for performance overall. And that's kind of how we view scale out or hyperconverged deployments like this.
Thank you, Scott. Dan, you're next. How would you like to answer this question?
Thanks, Mike. Sort of two ways to think about this, or two aspects to the response. I think the first is sort of how we internally view it, direct answer, and then the second part of it is really the key questions that customers need to ask. So starting out, you know, scale out is typically correlated to an architecture that can be, you know, cluster multiple systems together to meet the performance and capacity that the customer requires. So what's often not talked about is the unique multiple dimensions for a scalable architecture that are needed to match the changing dynamics of the customer's workload. You know, we need to have a conversation about scale requirements such as scale up, where additional shelves can be added for capacity within a system without needing additional processing power. Additionally, many customers' environments, including service providers, need the ability to scale down, which is also very important as well. Just spikes in customer workloads and deliver on demand when the storage is needed at a particular point in time. So this sort of approach to scaling up, scaling out, scaling down is composable storage. You may have heard of that through some of the other analysts out there who talk about that. You know, as an example, we have a platform that we'll be announcing shortly that is designed with composable storage in mind and allows you to disaggregate the storage systems and management software control for visibility and access to each individual level drive. It's also sort of innovative in the packaging and the way we deliver this extremely dense form factor, which you'll hear more about at the announcement that's coming up. You know, we're able to achieve with these sort of systems, you know, tremendous throughput, 61 gigabytes per second, you know, using just over 600 gig ports, you know, 15 million IOPS over the same 600 gigabit ports, 64 gigabytes bandwidth between the servers in this box. So we've got some very high-end platforms rolling out that are just sort of pushing the limits of what's possible, and therefore also opening up new applications. The second part to this, when you think about key questions, there's three questions we think are important for customers to ask about scale out. How large can I scale? You know, the key to successful scaling is the balance between first accommodating the capacity growth without disrupting the customer environment, and second, delivering performance needed at the desired capacity point without any impact on application workloads. So that's an important question. The next is, how much does it cost me as CapEx to scale? You know, there's an initial upfront cost for scale out design, the incremental cost to add nodes to the cluster, and the future impact of new type of nodes, and the ability to either mix and match or be faced with forklift upgrade are all important factors. So successful scaling should be non-disruptive and provide plug and play of storage solutions with scale out storage solutions in the future, from today and in the future. And the third question is, what impact does scale out have on my OpEx? It's one thing to be able to scale out, and another thing if you need an army of skilled professionals to plan and operationally manage the potential upgrades to achieve the scale out. So successful scaling should have a storage solution that accommodates scale out upgrades with automated tools and simplicity to implement with, you know, complete transparency to the customer environment. These are very important aspects. And, you know, at New ISIS, we have a broad solution portfolio of storage array and storage serving solutions to meet the greatest level of flexibility. We have the industry's fastest and most dense all-flash array in the market. We have the highest capacity cold storage platforms in the market today. And we have true leadership, company leadership addressing various vertical markets, such as storage for streaming video systems and other major accounts that we've been deployed at for years. So anyway, that's sort of our snapshot view, Mike. Thanks very much.
Thanks, Dan. And Josh from Celera, what was your guys' view on scale out?
Well, Dan and Tom both touched on great points. And I would say what's most important in scale out now is to really embrace scale out the way the hyperscalers have embraced it. And what I mean by that was hyperscalers showed that you could pick your version of homogeneous hardware and make that hardware work for you by deploying different software types. So this also caused a rethink in the application, and we've seen all these applications that have gone scale out. What they all similarly do is they take a problem, much like HPC did for years and years. They take a problem and they divide it up into multiple hosts. And we've applied for NVMesh, that is, that same methodology for the storage platform itself. So rather than putting our intelligence in servers, such as Sanmina has some very nice offerings for servers, yet at the end of the day, they are restricted by the designs that they get from either Intel or AMD. That is, if you're connecting NVMe drives and you're putting networking on there to access those, you're limited by the number of PCIe lanes. You can put expanders on and you can stuff it in, but if you're limited by that CPU architecture. So we believe that you have to be really, really flexible and allow drives to be spread over many, many hosts. Use those as if they're local, because the intelligence is within the client side itself or the initiator. So we spread out the intelligence of our logical virtual all-flash array over all the clients themselves. We don't tax the CPUs of the targets at all. We literally, without a specialized hardware card, we completely offload the transport on the target side. So this enables what what Tom touched on when he talked about convergence. You can literally have your application servers with NVMe logically disaggregated. Dan had mentioned the importance of being able to disaggregate, and we 100% believe that. Only we can deploy physically disaggregated, where you make servers just be storage, or we can logically disaggregate, where you have NVMe in each server, and we don't tax that server for remote people using that NVMe. We literally put 0 CPU load on. And so I think, to go back to the question, the key thing as you get these scale-out solutions and design now is to design in the true philosophy of scale-out, and that is distribute the processing, don't put the intelligence in central controllers. Really take advantage of the fact that every single server has a whole bunch of cores and a lot of processing power, and the aggregate of all that is much, much higher and more valuable than locking down in centralized controllers. That's it.
Perfect. Thanks, guys. Let's go ahead to the third question. This is one that I've heard from a lot of people looking at NVMe in general and scale-out flash as well. But what do you see as the killer apps for a scale-out flash solution, and what are the best practices for maximizing the value of scale-out flash solutions for these use cases? And we can spend a little extra time on this since the audience polls aren't apparently not working. So, Dan, I'll start with you at New ISIS. What are your thoughts on killer apps for NVMe and for scale-out flash?
Okay, thanks, Mike. So we have two thoughts again. There's sort of the first thought is from the enterprise perspective, and then the second thought would be around, talking a little bit more around specific example in a little more detail. So, obviously there's many killer apps that we see emerging with our customers. We sell across platforms to the hyperscale folks in very large fashion. And the four areas that are worth highlighting right now would be, the first one we see is big data analytics applications. So these are the things you'd expect: artificial intelligence, machine learning, IoT. The second is virtualization and container infrastructure, addressing the high performance requirements of applications across distributed data centers and private public cloud deployments. Third would be OLTP, to address the core mission critical applications that demand the highest levels of performance, scalability, low latency, coupled with the requirement for non-disruptive operations. And then the fourth piece is business continuity, solutions for nonstop operational systems, which typically need scale out in an overall enterprise framework to address the on-premise data center integrated to cloud storage environments of the hybrid model. So these, the best practices around this, I'd say there's sort of 5 key considerations. There's certainly many more, but sort of 5 key that are worth hitting on. Service level objectives of the customer for the overall performance of the entire workload, and QoS of specific applications to meet customer performance expectations is one of those. having a retention strategy of information assets and lifecycle management of data from creation to long-term archive. Also, high availability and capacity on demand with scale-out design that can non-disruptively address adding capacity or new levels of software with no planned downtime. Fourth, data protection addressing all aspects of security information assets from disaster with snapshots, backup, and replication between the on-premise and cloud storage infrastructure is also very important. And then lastly, global security and access control with the ability to address corporate governance, regulatory mandates, and privacy protection utilizing encryption, key management, multi-tenancy, and other techniques is also one of the 5 important considerations. So, the future for scale-out flash storage will incorporate all of these best practices along with unified storage strategy that can address any data type, including files, databases, objects. Without scale-out design for these killer apps, customers historically had separate systems for each type, and that was very expensive and added tremendous CapEx costs as well as OpEx. So, when I think about this, and we talk about this also from the perspective of an example, a killer app for scale-out flash storage is real-time data analytics, sometimes referred to as big data or fast data applications. This killer app relies on 3 vital functional components to meet the requirements. You have to have high throughput storage for data ingestion. You need to have distributed in-memory database for data processing for this particular application. And then thirdly, you need low latency, high bandwidth networking for clustered servers. So, with New ISIS, we have a storage solution that overcomes these challenges so that enterprises can break through today's memory limits, enabling new possibilities like accessing higher capacity in-memory data sets to deliver better, faster analytic insight. An example of this would be, cloud providers can reduce capital costs for memory when allowed to oversubscribe their workloads with greater overall capacity. Or high-performance computing centers can increase large memory data sets to improve research and scientific results and test new simulations quickly and cost-effectively. So scaling these deployments involves the addition of server nodes to expand the aggregate amount of memory RAM available in the cluster. But adding servers unnecessarily increases compute CPUs, and this negatively impacts return on investment. So for this sort of killer app, New ISIS has a real-time analytics engine solution that overcomes this dilemma by allowing non-volatile memory, NVM, to complement RAM to expand the addressable memory available for server nodes running in in-memory databases. So we can expand beyond the box. We actually have a planned demonstration at the Flash Memory Summit coming up in 2 weeks, where we'll be, hitting on the following killer app. We've just taken, again, third-party interoperable components, tied together a solution that is industry-leading, high performance, and pretty compelling. So in this particular example, we've got one of our New ISIS storage servers that's serving as a Kafka distributed streaming device. We've got one of our new NVMe Optane storage array, so full of Intel Optane drives for memory extension via the Intel Memory Drive technology, IMDT. We have to use an MP Store software package for persistent storage as part of this. And then we have 2 industry standard servers for just running MemSQL in an in-memory database clustering. And then we have some Mellanox switches. So you can see components from all these vendors providing an integrated, incredibly cost-effective, and terrifically high throughput performance sort of leading edge solution there. So the benefits of this real-time analytics engine is that it includes greater scalability at lower prices and low impact performance versus an expensive memory-based solution. For example, this demonstration will show a reduction in cost of less than 50% versus it'll cost less than 50% versus conventional RAM-centric solution while delivering over 85% of the equivalent performance. So this is, just understanding the customer needs and providing a solution that gives you a dramatically better, overall more efficient package and solution in a cost-effective fashion. So that's sort of our view there. Thanks, Mike.
Thank you very much, Dan. Josh, obviously you guys are right in the middle of this. What's your kind of view on killer apps, and what do you see your customers actually utilizing scale-out for?
Well, it's going to be hard to follow up on Dan's answer because he covered an awful lot of it. So rather than just say ditto, I will reiterate that I do believe in a lot of the use cases that Dan pointed out. And it's a lot of the buzzwords, so I don't want to just rattle off buzzwords. But yes, real-time analytics. Video analytics is something we see because of the massive bandwidths that we can do and that scale out. can do. Very large databases. And AI and machine learning, absolutely, positively. But you might be sitting listening on the other end of this conversation and say, well, yeah, I do those things already, but I just put local NVMe inside the servers. That's how I do it. If you're deploying any of these in-memory databases, for example, take your pick, Cassandra, HBase, Mongo, any database that counts on having a lot in memory, best practice for that database is to go ahead and put a local flash device, and you'd probably want to choose NVMe with that database. And that's because during startup, it's going to read from that drive. During shutdown, it's going to dump to that drive. And if there's any in-memory table misses, or the database expands beyond the physical memory of the system, it's going to go ahead and use that drive. So you want the lowest latency possible. So ask yourself, do you really want to have to choose a certain size drive? Do you want to have the limitations of the physical hardware? And that's what I think is important. Any application for you is a killer application if you have decided that you have to use NVMe flash. If you're putting NVMe flash in your servers, but you don't like the physical limitations of that, you don't like to have to choose servers that take NVMe, you can buy systems from Sanmina. You can contact Dan, and you can buy systems that take either Optane. We've worked with Optane remotely. We do 14 microsecond remote reads and writes against Optane media. So if you want to go ahead and extend virtually the memory of your system, go ahead and use us and use Optane and get 14 microsecond remote reads and writes. And yet you can also then choose to have redundancy if one of these drives fails. With automatic failover, you can have host failure. So the killer app is whatever you want it to be, where you've chosen to use local NVMe. But best practice would be to break the bonds of physical locality, allow it to be remote. Operationally, allow you to use a particular type of server that can be serviced, whereas your compute nodes can be any form factor. They just need to be able to take a network card. Go ahead, use your killer apps, whatever they may be in this space, but instead of doing local NVMe, do remote and have the same speed access. And the best practice basically is to match your NVMe drives to your network bandwidth. And then you're going to extract all the dollars you pay for this expensive media. You're going to be able to use it remotely and get every bit of IOP and throughput performance out of that. That's it.
Excellent. Thank you very much, Josh. That was a great answer. Scott, finishing up with you, what do you guys see as killer apps for scale out?
Well, following Josh and Dan isn't going to be easy. I was going to say big data analytics too, also combined with AI and machine learning, because data at the end of the day has to serve the companies that are collecting it, right? If we take a look at some of the more easily recognizable, understandable things that everybody can latch onto, we look at things like Siri and Alexa, right? Both of these are huge business drivers for Apple and Amazon, right? But when you boil it all down, the concept of taking an audio fragment that you recorded, shooting it up to a cloud, processing that audio into some sort of natural language, then doing a natural language query to figure out what the heck they really are looking for, and then taking that query and turning it into an actionable bit of work is a huge amount of processing power, and it requires many, many servers to do it. Just taking the concept of, Alexa, reorder dog food, and imagining how that turns into food for Fluffy over the next month is just a non-trivial amount of computing power. And people expect an answer in a few seconds. I mean, if Alexa doesn't get back to you in 3 or 4 seconds, you're like, oh, wow, is my network working? Is, Alexa doing her thing? I mean, the human factors of this are really important. So being able to, reduce latency at every turn is important to this whole process. And this goes beyond, obviously, just, Siri and Alexa to things like facial recognition and self-driving cars and object recognition and all that. All this stuff takes enormous amounts of compute power and dozens, in some cases, hundreds of servers to make that happen. So every time the data, enters and leaves a server, there's an opportunity there, at least, from a Solarflare perspective, to reduce the latency of that transaction. And if we can shave even, a microsecond here or there, they all add up at the end of the day. So latency really does matter, especially in the NVMe space. And SolarFlare is probably the best partner you have on the networking side to make that happen for servers. So that's kind of our take on the whole big data angle to reduce some latency. Thanks, Mike.
Excellent, Seth. Thank you very much. Great answers, everybody. Now we'd like to open up to audience Q&A. If you have any questions, please use the Q&A window on your Zoom to post that question. I'll read it off, and then we'll let the panelists each take a shot at answering it. So go ahead, and if anybody has any questions, please go ahead and type them in. And just as a reminder, we will be sending out a link to everybody who registered for the webinar, so you can see the recording and the slide set. That should go out within 24 hours of the finishing the webinar. Well, guys, it looks like we don't have any questions at this point, any Q&A from the audience. Again, so let's go ahead and wrap this up. Again, I'd like to thank Josh and Scott and Dan from Accelero, SolarFlare, and Nuisis respectively for hosting this webinar and for providing all the great information that they provided. Wait, we have one question. Go ahead, Rakesh, if you could type in your question. I'll read it off and we can let the audience, the panelists answer it. Okay, so Rakesh's question is, in the panel's opinion, what is NVMe over Fabric a good solution for remote persistent memory? Scott, why don't you go ahead and start with that, and then we'll go through, we'll let Dan talk to it and let Josh talk to it. So the question is, again, what is NVMe over Fabric good solution for remote persistent memory?
It can be, for sure. The fact that the latencies have gotten down to the realm of memory. They're not quite memory, but if we all remember the 4 performance curves from our comp sci classes in college, disk and I/O used to be way out there to the right, and CPU and memory were kind of in the middle. We've since kind of crushed disk into networking and pulled networking down to almost memory level. I mean, when we're talking about network accesses, I mean, in the microsecond range, we can actually, in some cases, in electronic trading, for example, we've got use cases where we're doing network transactions in under 100 nanoseconds, right? That's not quite local memory speed, but it's, in the same or similar orders of magnitude. So yeah, it's very possible to use flash over NVMe over fabrics for an extended memory solution.
Excellent. Josh, what do you guys see from Accelero and along this line?
What we see really, unfortunately for Rakesh, is a your mileage may vary answer. So what I mean by that was it's such a broad question. I'd agree with Tom that it's easy to say yes, but for example, in Tom's space in SolarFlare, he's mentioned online trading. My understanding, and Tom, please correct me if I'm wrong here, is the trades are all going to be done with systems using SolarFlare adapters for very, very low latency access between the systems, in the system's memory only. All these transactions are going to take place only in DRAM. Having to go out even to Optane, even to local Optane at 9 microseconds, is such a difference from the nanosecond access range of DRAM that the live during the day trading is only going to take place in DRAM, and using solar flare adapters when the machines have to talk to each other, they will. But in the evenings, when the markets are closed, all these financial firms have to test their algorithms and tune them. They do back testing. This is where using remote non-volatile storage is fantastic, because the data sets may be larger than the flash that you can stuff into any one system. And you want the highest bandwidth and lowest latency, because the lower latency is going to let you simulate more transactions from the day. So you're going to take that tick data from the day. And this is really showing where all these solutions, the Sanmina platforms, the solar flare, NICs for day trading, and then the non-volatile remote access to storage, you can mix everybody on this call together into one solution. And if you want to call that persistent memory used for backtesting an extension of memory, that's where you can do it, because you probably can't make a machine that can hold the entire data set. So it's going to give you the best option to go ahead and do that.
Excellent. Dan, what's your guys' view on this?
Thanks, Mike. Well, I think that Scott and Josh really hit it. But I'd like to add that I just feel like this is a new and evolving space. I don't think all of the infrastructure is in place yet today to have a fully robust, remote persistent memory solution running all of the applications that you might wish to today. But that is coming. And so if you think about even the demonstration I've mentioned a couple times now, the NVMe over Fabrics demonstration, that was the whole point, right? If you're only talking about adding 5 microseconds to 7 microseconds of additional latency, and yet you can have that memory on the other side of a 100 gig connection, that is a huge advantage. And for most applications, that is totally fine. It's awesome latency and it's behaving like it's local. It might not be ideal for live real-time day trading, as Josh had mentioned, but it is applicable, as he mentioned, also for the evening and the remote processing afterwards, the simulations and that sort of thing. So I think tremendous market potential. I think it's one of the specific things and reasons that NVMe over NVMe OF is being developed, and we've already seen it, and that's why we're sort of showing that out there. So the idea of improving efficiency by separating your CPU from your storage and having that flexibility to assign and allocate with a latency level that's very similar to what you would expect inside of a box is exactly why we're all here, I think, and is something that's compelling and exciting. And again, a year ago, we showed that, and we can talk to that and be happy to chat with anybody who'd like to afterwards about platforms that allow that and what other complementary components you might need to do that. So that's our snapshot view. Thanks, Mike.
Mike,
excellent. Yeah, and Rakesh, go ahead. Go ahead.
Dan and Josh made some great points, but one thing we need to keep in the back of our mind is a lot of operating systems, page out to storage, to create more virtual memory for what it is they're doing when they're doing processing. And forever we've been used to that paging out to storage being the spinning disk, right? And so I think that kind of goes towards the question to some degree. I mean, we're used to that, that secondary or even tertiary, offline memory popping up, from the spinning media, and moving it to flash, especially even flash over a network, is a huge gain over what we're used to, right? So, I mean, a lot of people on this call are at least, that are participating in the webinar, we're kind of so jaded because we've been so close to NVMe for the last few years, and in the microseconds, in some cases nanoseconds, that, thinking about there are still systems all around us that are using spinning drives for, local memory storage, to virtual memory, that, even, NVMe over Fabrics would be a huge improvement over what those systems are used to today. So just something to keep in the back of our minds as we look towards this problem.
Excellent. And Rakesh, I know I saw you asked a follow-up question. Are there any reference architectures available for this? If you can send me that question in email, I will get it out to the panelists and they can answer back to you. So happy to help you out on that one. Are there any other questions from the audience? I don't see any other ones out there. All right. Well, I think we're hitting the end of the webinar. Again, thank you, everybody. Thanks to Dan and Scott and Josh for both hosting this and for providing all the good information you've provided. I've certainly enjoyed the discussion. I hope the audience has too. And again, if you have any questions afterwards, feel free to send them to me and I'll get them out to the panel. Also, we will get you a link to the webinar recording within 1 hour or within 24 hours. And they'll be sent out to everybody who registered. So again, thank you for attending, and I hope you enjoy your day.
Thanks for hosting, Mike.
Thank you.
Thanks everyone for listening.
Thank you. Take care, everyone.
Bye-bye.